All right, welcome back. So we're gonna jump into example number 5, and so it's gonna be the same thing as finding the actual real um, the original function given extra information or particular conditions of the function. So your company determines that the marginal cost C prime of producing the x unit is given by the function C prime of x equals 10x plus 9. That makes sense. That's the definition, right? Find the total cost function C, assuming that C of x is in dollars, and that the total cost of producing 79 units costs 34,806. All right, so they're giving us the marginal. Here's the marginal. They're asking us to find the original cost function, right? And they're also telling us that when you produce 79 units, it costs you 34,806, right? That's what we can get this line from here. The total cost is C of producing 79 units. It cost $34,000, right? So that's what we get from this line. We also are getting that C prime of x is equal to 10x plus 9. That makes sense. And so the goal is to find C of x. So as we mentioned in the last video, the difference between those two is that this has a derivative. This is a derivative of this. So is there a way to undo this derivative? And the answer is yes, right? We can undo the derivative by taking the antiderivative. And whatever we do one side, like we do in algebra, you gotta do it on the other side. So this will cancel each other out, right? Giving us C of x, and then the integral or the antiderivative of 10x plus 9. All right, so let's do one term at a time. Let's focus on the first one. To take the antiderivative of 10 times x, we have to do the constant multiple rule. That means you take the constant and then multiply by the derivative of the function. The derivative of x, we always having a imaginary 1. So the derivative of x to the 1 using power rule is add 1 to the power and then divide by the new power, followed by the plus 9. When you add a constant and you take the derivative of that constant, you take the antiderivative of that constant, that means you add a factor of x, right? And followed by plus c. So if we simplify this is going to be 10x squared over 2 plus 9x plus c. If you notice here, the 2 and the 10 will cancel each other out or simplify each other out, giving you 5x squared plus 9x plus c. All right. So now what we're gonna do here is we have found the total cost function partial, right? Because we still have that c. So at this point, to find that c, we can use the other information they give us. That is this one, right? We know something true about that function. We know something true about this function. What is that thing? Is that whenever x is 79, right? The total of this is 34,806, right? So that's what we're going to do. We're going to go ahead and plug in 79. And this should equal 34,806. So if we put this in the calculator, right, let me look at my notes. We should be getting roughly something between 31,916 plus c equals to 34,806. And then we gotta solve for c, right? Solve for c. So what do we do here? We just subtract 31,916 on both sides of the equation. So that leaves us with C is equal to um, 34,806 minus 31,916 gives us 2,890. So that means that the total cost function is 5 times x squared plus 9 times x plus $2,890. All right, so we found the total cost, right? And again, this was done by knowing a little bit more about the function, right? And that's where we use this, right? All right, so now at this point, we're gonna use this to answer the next question. How much cost should be expected from producing 100 units? Well, remember that x is the units, so x equals 100. So what we're gonna do here is we're gonna use the 100 and plug it in every place we see an x. Okay, and if we do that, then and put this in the calculator, we should get 5,300,790. So C of 100 is that. So it's gonna cost, total cost is $53,790 to produce 100 units. Anyways, let me know if you have any questions. Thank you so much. See you next time. Bye bye.